Hello.
Yeah, you're good. Ready to go.
I'm good. All right. So this is a presentation I've given a couple of different times, but I continuously update it with new data that I'm getting in. I want to share it with all of you this afternoon, and I will, of course, post it in the Slack channel when we're done here. It stems from a lot of the information that we've collected over the years in the DevSecOps survey, community survey that we talked about earlier today. And it also comes from the State of Software Supply Chain report that we've published each of the last 3 years, and I will begin writing the fourth version of that report beginning next week, now that the Nexus User Conference is going to be wrapping up. So the journey here really starts with the first way of DevOps. It's something that we've all read in the Phoenix Project, released by Gene Kim and others in 2013. The first way of DevOps, as you remember, was emphasizing the performance of the entire system and never passing a known defect downstream. And I think that, as you've heard from a lot of the talks here from David at TaskTop, from Barry at Fannie Mae, from Jasmine at Delta Airlines, and others that have been on with us throughout the conference here, their organizations have really embraced this concept. And part of embracing that is understanding how DevOps is really working within their DevOps tool chains, that you have feedback loops that you've built throughout your organization where you've automated the process to check something in. When you check something in like that, with each check-in, there is a trigger. And at a trigger point, in the first trigger points, if you're actually getting to these points here and there's something wrong, either a functional defect or a non-functional defect, you're automating the feedback loop for those particular problems and surfacing them back to the development teams to then fix and recheck in that code to move it down to the happy path here at the bottom, where we're able to go through each stage of the development lifecycle, testing and deploying into production. So when you think about this, never passing a known defect downstream says when you do, you're going to hit a trigger point that's red and send that automated feedback loop back. Well, this is extremely important in organizations that have and manage their software supply chains. And this is just what David at TaskTop was just talking about in the previous session. It's what a lot of our other customers have been talking about. And effectively, the way we look at this, and a good way to look at it as an analogy to manufacturing, the software supply chain really behaves like any other supply chain in a manufacturing industry. It has suppliers, or the open source projects in this case. It has centralized warehouses or the component repositories, so Maven Central, npm.js, rubygems.org, the NuGet Gallery, etc. And those components are absorbed by or downloaded from the manufacturers in the software supply chains. And that's really all of the software development teams that you've been hearing from throughout the conference here. Those components are then turned into finished goods or software applications. If you think about this, for open source components, they work across this software supply chain as they're feeding into and through your organization. The same thing holds true for containers. If I create a containerized version of an application as a supplier, I put it up on Docker Hub, your development team downloads that container and deploys it into your environment. That also is effectively a software supply chain. Every single one of you listening to this presentation that has a development team has a software supply chain. And that software supply chain is working at tremendous volume and tremendous velocity within your organization. To give you a sense of the volume of supply that is out there, we've gathered this information from the State of the Software Supply Chain report that was published last year and the previous years. Almost 1,100 new open source projects come online every day. Across every version or across every open source project globally, there are 10,000 new versions of projects that release every year. Across the average open source project, they do 14 new releases of their code every year. So there's a tremendous amount of supply that of open source components that are out there across these different repositories, across these different open source projects. And this is helping us expedite the velocity of our DevOps pipelines, our DevSecOps pipelines, CI/CD development. Why, create from scratch what you could download from the internet in a second that someone else has created for you. We've seen this velocity of consumption grow exponentially over the years, and in each year that we've been tracking the download requests from the Maven Central repository. When I joined 4 years ago, or over 4 years ago at Sonatype, we had just completed 13 billion download requests. Last year, we just saw 87 billion download requests from Maven Central. There's a huge amount of benefit, as I said, coming from this because it's making our software development efforts more efficient on a global basis. If you look beyond the Maven Central repository to what's happening in the land of JavaScript packages, the NPM repository is seeing amazing amounts of traffic. So this is a screenshot from Laurie Voss, who I follow on Twitter. He works at NPM. He posts stats regularly on this repository. This is from April, but I'll tell you, I'll walk you back to November 2017. So 5 months before this, he put out a tweet that said, NPM users just downloaded 4 billion packages in the last 7 days. And literally 5 months later, he said, NPM users downloaded 5 billion packages in the last 7 days. The growth that they've seen is absolutely tremendous. And this is because, one, more people are using open source. There are more automated tools out there that are being used to download open source components to bring them into our organizations. And as we were discussing with Helen Beal earlier today, a lot of organizations are really kind of unaware of how much open source they're using in their environments. Even Barry Schneider from Fannie Mae had mentioned, before they did an analysis, they had approved 800 components to go into their environment. But when they did the analysis, they found they had 13,000 unique open source components in their application portfolio. So the volumes are tremendous. The result is that 80 to 90% of applications that you're building today are composed of open source components. It's not just a Sonatype stat. You've heard it time and again through the presentations here, through the various companies that have presented. And when you think about containers and containerization and how much Docker adoption, OpenShift, Amazon, Rocket, Kubernetes have come into play, there are more and more containers out there that are coming into our environment, not all of which we've created ourselves, but we're bringing in from external sources in the software supply chains that we use. But even as we see all of these productivity gains and efficiency gains in our development and operations practices, we need to know and be aware that not all of these parts that are being used are created equal. That some have known security vulnerabilities. As we've heard from previous presentations here, there are license risks associated with some of these components. Some of these components are really old, where many newer versions of those exist. So a component released 10 years ago might have 140 new versions that have been released on the market since. But I can tell you A lot of those, 6, 7, 10-year-old components are still being actively used in development today that we're seeing downloaded. So what is, when we track some of the data behind the hygiene around this consumption, we've been looking year over year at the percentage of vulnerable components that are downloaded, known vulnerable components that are downloaded from the Maven Central Repository. In 2014, it's not shown here, but we were at 6.5%. We saw year over year declines to 2015 to 6.1 and 2016 to 5.5%. And in 2017, we saw 12.1%, or 1 in 8 components downloaded with known security vulnerabilities in these environments. And this is, we don't yet know why. We're still exploring why the percentages went up dramatically. One of the theories that's going around is that our data research practices have improved dramatically over the years as we've put more automation, more intelligence and machine learning around it, and we've gotten more sophisticated, that it may be that the previous year's numbers were understated because our data research was not as good at those points, and that we're now seeing a truer reflection of the number across the community. But it's still alarming, because if you're not tracking what's coming into your organization in terms of open source components, what's sitting in your Nexus repository, or what your automated build tools are pulling down, if you're not checking for the quality of those components from a non-functional standpoint, you may be electively introducing this risk into your environments. So, no one out there is pulling down 1 billion components into their environments. For this year's software supply chain report, and this is data that we'll publish later this year when the report comes out, but I looked at 7,500 different organizations. The average organization is pulling in 170,000 Java components, 3,500 of which are unique. And in this set, about just over 11% of those components downloaded had known vulnerabilities associated with them. Now, if you're like any of these organizations, or the organizations that have presented throughout the Nexus User Conference here, you'll know, you're not just developing in Java, you're developing in Python, you're developing in .NET, you're developing in Ruby. So when you are, these numbers from 170,000 are boosting to, 300,000, 400,000, or 500,000 components that you're absorbing into your organization that may, vary by quality significantly. Right? So how do we monitor or manage these components coming into our organizations? As we've said before, there are 6 in 10 organizations that we've surveyed have an open source policy in place. This data comes from our 2018 DevSecOps community survey. We've seen this pretty consistently over the years that we've done the survey, that it hovers around 57 to 63% of organizations. Now, the interesting thing in this year's survey that we saw is when we ask, does your organization have an open source governance policy? Those organizations with no DevOps practice said, 58% of them said, yes, we have a open source governance policy. And 77% in mature DevOps organizations have a policy in place. But in the no DevOps practice, 46% ignore it. And I think that means the effective rate is about 23% of those organizations have a policy and their developers and DevOps teams are following it. In the mature DevOps practices, where you actually see more automated governance of open source policies, you see less of an ability to ignore it, because automation is difficult to ignore. When you're telling your developers and surfacing the information for them about license information, about security information, about the age of certain components that they're bringing into the organization. And you're doing that inside the developer tools, whether it's Jenkins or an Eclipse IDE or Visual Studio. It's hard to ignore it, and more people are complying to that kind of policy. So for the organizations that have policies and don't follow them, for organizations that don't have policies and are absorbing large volumes of open source components, we see these components, the vulnerable ones, making their way into production. So in Northeastern University last year, they did a report called "Thou Shalt Not Depend on Me," and they studied 133,000 websites that were using JavaScript packages as part of their web applications. And what they saw was that very popular versions of open source components were being used, that severely outdated versions of those components were being used, and many of the very popular ones were also vulnerable versions of those components, when completely safe versions of those components were available to them. The reality of this is, and it comes, again, this comes from our 2018 DevSecOps community survey, is that we're seeing more breaches related to open source components in development in these DevOps environments. So this year, 3 in 10 organizations had or suspected an open source related breach. This was, months after the Equifax related breach, when we're querying these people on, have you had or do you suspect a breach? But it's also 4 years after the Heartbleed vulnerability was announced. In 2014, we ran this survey right during the month of April. That's when the Heartbleed vulnerability was announced. So you would suspect that huge vulnerability that received global attention would get more visibility for the people taking the survey, and it would have boosted the numbers sky high just because of that awareness. Same would hold true if we held the survey in September 2017 when the Equifax breach happened. You would expect to see a bigger jump. But when that was 14% of the people that took the survey, to see 4 years later, we're 121% worse off, that more breaches are happening, more open source is being used, but it's not being governed as well. We're not keeping track of our software bill of materials. We're not looking at the vulnerability for this, and we're paying the price. And the adversaries know there's an easy path into these organizations to breach them through these components. So as the title of my presentation says, we're all Equifax. These open source components are making their way into production. And while Equifax was in the news in September 2017 for a breach impacting 145 million consumers and their credit details, at the same time, that particular vulnerability that they were linked to was from March 2017. In March 2017, if you look back at the news, Okinawa Power, the Canadian Revenue Agency, Apple, Japanese Post, the GMO payment gateway, those were all impacted with sites going down from a known struts vulnerability. We documented many of these in our State of the Software Supply Chain report last year. Then in March this year, India Post and the India Social Security system were also impacted by struts-related vulnerabilities, where they announced, either they directly announced or it was reported that they had struts-related breaches in those organizations. So months after the Equifax breach, we're still seeing struts-related breaches of vulnerable struts components being used in production. Equifax was not the only one that was impacted here. Now, if we look at the Equifax, I think we all know the Equifax story, so I'm not going to spend a ton of time on this, but I think one of the important things to recognize here is that the vulnerability related to struts in this particular case, the CVE 5638, was announced on March 7th. Equifax, the initial breach of Equifax was reported to be on March 10th. Equifax had 3 days to understand that the vulnerability had been announced and to update their systems in a way that they could not be breached. They had 3 days to take action. When you look at Gartner's report of how long it is between the time a vulnerability is announced and the time that a system is exploited from that vulnerability, in 2006, it was 45 days. 10 years later, it was 15 days. And last year, in the case of Equifax, it was 3 days. When I was in London a couple of weeks ago, Daniel Cuthbert from Banco Santander reported that from a criminal perspective, the hacker mind, the great hackers out there, if there's a vulnerability out there, they're able to get into your site or your applications within 8 hours, right? So if you think about how fast do you need to know, how fast do you need to be able to identify what you have in production, what's in your apps, what's a priority to fix, how fast do we need to be? It's not just about DevSecOps making us faster, it's about getting the fix when it's needed in faster. As I talked about earlier in the day when I was at a DevSecOps meetup at Fannie Mae, they had a vulnerable struts component in their production environment. And they didn't freak out. They just took their normal process to deploy a new business requirement into production. And that process takes 2 days for any business requirement. They just saw updating their struts component as a new business requirement. And it took them 2 days to update that, which would be under that 3-day window that Equifax saw. So the kind of crazy thing when you look at the environment overall, it's not just Equifax and Apple and the Japanese Post and Canadian Revenue Service. When we look at Maven Central and we look at the number of vulnerable components, versions of struts downloaded every month, in March 2017, it was just over 100,000 vulnerable downloads per month. That dropped the following month, following the vulnerability disclosure, to about 80,000. So there were organizations paying attention to, we shouldn't use the bad versions of struts, let's stop doing that. But then you see a very consistent, 80,000 or so per month downloads of vulnerable versions of struts. And in November, it almost peaked again toward 100,000 components. Now, you may say, like, yeah, I know struts is really bad. We don't use struts in our environment because it does have such bad hygiene. We're using Spring. And Spring actually has a similar pattern within its community. When we look at the vulnerable versions of the Spring framework, we see anywhere between 70 and 80 or so, 85,000 or so downloads every month. There was a major vulnerability discovered in the Spring framework back in September, and you really see, very little trail off in percentage of downloads year over year. In December and January, there's less development happening during those times because of vacation time. So that's actually where you're seeing some of that drop just by the calendar year in this. But the volume of vulnerability of vulnerable components that are being downloaded when safe versions are available has been very eye-opening within our research. As we've shared before, there are companies that are automating security across their development lifecycle. And we're seeing this with DevSecOps practices and mature DevOps practices. Automated security is coming into the lifecycle, throughout the lifecycle, 338% more often than organizations with no DevSecOps practice. So DevSecOps is real. It's happening at scale. When we look at what security tools are being used in these organizations, when security is being automated, it's WAFs, it's container security, containers, again, being part of the software supply chain. Open source governance that we've been talking about, more organizations are deploying that in order to help them better defend themselves and deliver high quality software and not deliver known defects downstream. And when you're able to do this, you're actually able to improve the quality of finished goods that are going to market. So those with managed software supply chains, and this comes from our 2017 software supply chain report, are improving the quality of their applications by almost 70% end-to-end throughout their software supply chain, from what's being downloaded to what's being deployed into production, right? So the question is really not, can we build secure software? We absolutely can if we emphasize it, more. But when we don't do this ourselves, when we don't take the responsibility to know what's in our software, to be delivering higher quality software to market, we're going to be held liable for it. Everyone's seen the GDPR legislation. Article 25 in GDPR says you need to build quality in. You need to build security into those systems. The White House, the FDA, Department of Defense, Underwriters Laboratory, 18F, OWASP, the UK government, French government, German government, they've all introduced policies or legislation or regulations that are focused on you need to build security into your development lifecycle. And again, we've documented these extensively in our blogs at Sonatype, as well as our software supply chain report annually. So when you think about this, when you think about how do we improve our DevSecOps practices, how do we improve how we're building software, it's really about emphasizing the performance of the entire system, understanding you have a software supply chain, that you're consuming these components and containers, and understanding what they are and never passing a known defect downstream. So that's all I have for today, and I think I finished on time, and Mark and I are going to do the wrap up here for the end of the day. So I will post these slides into the Slack channel. I will be in Slack if anyone has any questions or follow up here, and thank you all for attending today and being part of the Nexus User Conference.
All right, thanks, Derek. Derek's going to close down there and then be over here next to me. Or are you going to do it from there, Derek?
I'll come join you.
All right, so I'll see you in a minute or two. As I look back, I pulled up the schedule of what we've been through for the last 2 days, and seeing over 30 sessions, it's overwhelming to try to think about all the things and all the stories that we've heard in the last 2 days. I do want to personally thank all the companies that stepped forward and came through and really delivered content that's useful for the entire Nexus community. 30 sessions of practitioners. You had developers showing code. I was very proud of our customer service team. They did a great track.
Yeah, I got to miss it because I was running the other track, but I'll look forward to seeing the recordings for everything they delivered.
I see Chris Carlucci's in the Slack channel, been there all day. Thank you, Chris.
Yeah,
very much
appreciated.
I had a couple good sessions while you disappeared doing whatever you were doing. But David Slater from TaskTop, a remarkable story. It was great to hear that. I'm looking through the list. It's hard to mention everybody.
I kicked off with Barry Schneider from Fannie Mae, and a great presentation on what they're doing there, how they've introduced open source governance throughout their development lifecycle, how they've improved their code quality over the years, and what they've been doing there. Mohammed from Fox Intelligence.
I heard great things
doing, his live demo. You got to go back and watch it because he practiced that flawlessly, and the internet stayed up for him. So it all worked. But
he's a young guy. The demo gods were good to him today.
Yeah. So showing AWS and building a CI/CD pipeline with Jenkins and Terraform, Git, Nexus as well. Let me see who on throughout the list. So Stefania Chaplin, you have to check out her session. She did 5 demos in 30 minutes. Amazing. Went through Nexus staging. She showed Nexus firewall, in a Ruby Gems environment. She showed a JavaScript software bill of materials, really quick, but very straightforward. It wasn't rushed at all, but she's definitely a champion there in a session that I enjoyed there. James Wickett and Helen Beal, a wealth of information that they delivered.
Damn, James
and
was
shared.
a machine gun.
Always is, but I mean, the good thing is he uploaded his slides, so you can go back and read them in slower motion.
And Damon was the same thing. I know you didn't get a chance to see it, but Damon and James and Shannon Leitz, I mean, the real deal, the stuff that really can get you. I'll tell you what I was interested in seeing, because you and I get this asked all the time. The company gets asked all the time. How do you get ROI from using the tool? How can you verify the ROI here? And I heard a lot of times it has to do, I'll use David Slater as an example. The developer capacity increases so much when the tools are used like this that you can almost put a dollar value on the ROI there.
Yeah. I mean, we talked to Barry Schneider earlier today about, it was, not just bringing the tools in and what they were able to do, but he talked very explicitly about the pain points of when I started at Fannie Mae. It would take months to get, a single component approved, could take 3 to 9 months. And you either, ignored the policy or, you waited, but it would just take months and months to get anything done. He said, now we're doing things instantly, right? Now we're not wasting time. It's a better place to work. Like the cultural patterns, the satisfaction of the development teams just from, we don't have to wait, and we're using modern tools, and we're able to work, and we don't have to wait for people. They went from 100% manual reviews to 5% manual reviews. And those manual reviews are kind of elective, where they say like, surprise, we're going to, look at your application now and do a manual review. But, they reduced manual reviews 95% because they've automated, not just with our tools, but everything in their DevOps pipeline.
You had something else happen interesting today that I heard about. I didn't get to see it yet. The Red Hat demo. Explain what happened there. That was interesting.
So this was Siamak and from Red Hat and Curtis Yanko from Sonatype. They were doing a live demo. And in the live demo, they picked a component that was known vulnerable. And they said, we picked this. We can see that it's vulnerable because it's violated the policy, but we want to run this build. So we're going to waive that demo. And something happened where I don't think Curtis pressed enough of the right buttons to formally waive the component is to be, it's safe in this particular instance. So they ran the build. They were using Jenkins and the Blue Sky interface, which was really cool. And they're watching the build progress, and then it stopped. It's a policy violation. You can't move forward. We're not going to move this into staging. And Curtis was like, this wasn't supposed to happen. Maybe I didn't do that right. And we weren't butting up. We were butting up against lunch, so there was no speaker after him. I said, Curtis, go back and change it, run it again. And he went back, he pressed the right buttons, but went through, and it really showed like policy enforcement works. Automation is hard to ignore. And it was kind of a living proof demo there that happened live. It was recorded, so you all can go back and watch it.
Another thing that hit me that I heard a couple times that I hadn't thought about before. It started with DJ. DJ Schleen from Aetna, if you watch that one. And I heard it echoed through a couple presentations, is people are not failing the builds. They're setting warnings at the build time so that the app can move downstream and still get work on it. And then work on it in the process instead of failing it in place.
So this was shown in Siamak and Curtis's demo as well, that they actually showed how the policies are configured throughout the life cycle. But they showed early stage of the development lifecycle, they were warning. Later stage and staging and prior to release, they were breaking the build.
Right.
And we heard Barry say that Fannie Mae has gone to breaking builds because their developers are used to this. They started off by monitoring. They weren't enforcing anything. Then they moved to monitoring with alerts. Hey, developers, you're using something that's not good or not approved. And then they, matured further and went to, hey, we're breaking builds if you're using bad stuff. So it is part of the maturity curve and the process of adoption. Not everyone starts day one with breaking builds, even though it's functionally, possible. You got to get organizational buy-in and the cultural buy-in.
The other thing that I'm seeing to round out the whole 2 days is there are different versions of how you gauge the maturity of a DevSecOps organization.
Yeah, Larry Maccheroni, DevSecOps kind of scorecard that he used. Shannon Leitz had a DevSecOps maturity model that she represented as well. And I know there are other versions being built out there, but when you look at it, and we didn't have the GSA on, but they have a great, if you Google search,
that's John Giardini.
And Naveen Vimbar, who's the CTO there. We just had him present a couple of weeks ago in DC, but they have if you look under DevSecOps Guide for GSA, just Google that. You can find their maturity model there. Really super stuff, very detailed, in fact. So
that's a lot for everybody to catch up on.
Yeah.
Me too. I missed half because I was doing the other half, but from what I heard, I don't say it out loud usually, but I'm very proud to work here after what I heard the last 2 days.
It's it's really exciting. Not only were there exciting stories, one of the cool things for me in the tracks was, we start here in Washington, D.C., we go to Toronto, we go to Los Angeles, we go to London, we went to Paris, we went back to New Orleans. So you see a lot of the people that we have in the community around the world that are presenting, that we're able to contribute here without leaving home, and to have everyone watching who was at home, who didn't need to travel. So we could meet any organization, we can meet any organization anywhere in this format. So super happy that we could reach everyone and not have to force everyone to get on an airplane, stay in a hotel, find budget, and so forth. So I think this worked. I think we're going to do it again. I'm really happy to see everyone in the Slack channel.
Good night, Roman.
Yeah.
He's been up all night, 2 nights in a row.
Roman's been up all day, so really good to see him and others there. So thank you, everyone.
Yes, that's I hope to do it again next year. I think it's a great way to do it. All right. Thank you, everybody. Please enjoy the sessions. The Slack channel will be open if you want to participate and continue the discussions. It's going to be here as you watch the presentations. Jump in here, ask questions, and we'll keep an eye on it.
And the Capitals game starts in 2 hours, so go Caps as they try and win the Stanley Cup tonight.
All right. Thank you, everybody.
Bye.